Hi, Assalamualaikum warahmatullahi wabarakatuh. For the project, we chose Smart Irrigation System as the title. We are from Group 13, which is Muhammad Afizul Hazim bin Roman, Nur Atirah Amni binti Anwar, Nordiana binti Muhammad Masha, Erika Anak Thomas, and Muhammad Fikrin bin Muhammad Arifin. So, we are going to present our slides. For the first slide is project identification. The target user of the system are small and medium-scale farmers who often face challenges in managing irrigation efficiently due to limited resources. The project is planned to be completed within 15 to 16 weeks, which includes design, development, testing, and implementation phases. The estimated project budget is ringgit, covering hardware components, system development, installation, and testing. This project is identified as a smart irrigation system for agricultural water management. The main goal is to create an intelligent system that can monitor soil and environmental conditions and automatically control irrigation activities. This helps ensure crop receive the right amount of water at the right time, improving efficiency and sustainability. So for the next slide is project background and problem statement. In many agricultural settings, traditional irrigation systems rely on fixed schedule and manual control, regardless of actual soil moisture or weather condition. This often leads to over-irrigation or under-irrigation, causing water wastage, increased labor costs, and uneven crop growth. Furthermore, climate change has introduced unpredictable rainfall patterns, making it more difficult for farmers to plan irrigation accurately. As a result, there's a strong need for a smart, automated irrigation system that can adapt to a real-time environmental condition and ensure efficient water management. So for the next point, which is project scope. The scope of these projects include the integration of IoT-based soil moisture sensors and environmental sensors, such as temperature and humidity sensors, to continuously monitor field condition. The system also features automated irrigation control using water pumps and solenoid valves, which operate automatically based on sensor data and predefined thresholds. In addition, a cloud-based monitoring platform and mobile application will allow farmers to remotely monitor soil condition, irrigation status, and system performance. Overall, the system is specifically designed to be user-friendly, scalable, and suitable for small to medium-sized farmers. So we move on to the next slide, which is project location. The Smart Irrigation System project is proposed to be implemented at Kanga Place, Malaysia. This location has been carefully selected because it's surrounded by small to medium-scale vegetable and horticultural farms, which closely represent the target user of the system. The farming activities in this area rely heavily on conventional irrigation methods, making it a stable environment to introduce and evaluate smart irrigation technology. Additionally, the sites experience hot weather conditions and variable rainfalls, which are common challenges faced by farmers in northern Malaysia. This condition allow the system to be tested under realistic environmental scenarios such as dry periods and sudden rainfall to evaluate its adaptability and reliability. It also provides a controlled yet practical environment for system installation, monitoring, and data collection. This enables effective testing of sensors, automated irrigation controls, and cloud-based monitoring features without disrupting large-scale commercial farming operation. Overall, implementing the smart irrigation at this location allows for real-world validation, meaningful performance analysis, and potential future expansion to nearby farms if the system proves successful.
Assalamualaikum, my name is Hafizul Azim. I will present the project schedule overview. This slide shows the overall schedule for the project, which divide into four main phases. First phase, project initiation and planning, week 1 and week 2. During this phase, project objectives are defined, requirements are identified, and detailed planning is carried out to ensure smooth project start. Second phase, site survey and system design, week 3 until week 6. In this phase, a site survey is conducted to understand the field condition. Based on the finding, the system design for IoT sensor and automated irrigation are developed. Third phase, procurement and installation, week 7 until 10. This phase is involved purchasing the required equipment, installing the hardware, sensor, and irrigation component for all the projects. Final phase, integration, testing, training, and closure, week 11 until 15. Our system components are integrated and tested to ensure proper operation. Training is provided to user and the project finalized. And lastly, the project is officially closed. This is our project Gantt chart. Our Gantt chart represents milestone, description, duration, and week for the project. This is the network diagram for the project. This network diagram will show task 1 until task 9. The duration of the project is 105 days. For this project to run smoothly, several key of human resources are required. First, project manager. Project manager is responsible for managing the project timeline, budget, and overall condition. His role is to ensure that all project activities are complete on time and according to plan. Second, technical team. The technical team consists of engineer and technician. They handle the development and maintenance of IoT system, automated irrigation, cloud platform, and mobile application. Their role is to ensure the system operate efficiently and reliability. Third, agriculture specialists. Agriculture specialists provide the expert advice on soil type and crop water requirement. Their knowledge help to ensure that the irrigation system is suitable for different crop and farming conditions. Fourth, support staff. Support staff are responsible for pro- procurement, project documentation, logistics, and farmer training. They support daily operation and ensure all resources are well managed. Finally, training and coordination. All team members will receive additional training to ensure smooth operation and proper maintenance of the system. Good coordination among the team is essential for long-term project success. In conclusion, a skilled a skilled team combined with proper training and coordination will ensure the successfully implementation of the project.
Assalamualaikum and hi, my name is Nur Akira Amin. So now I will explain about the risk assessment and mitigation in our project. First, there are delay in procurement of IoT device. To reduce this risk, we order early and prepare backup supplier. Second, we have faced technical failure during the system integration. We solve this by testing the system step by step and getting help from technical experts. Third, there is a risk in accurate sensor reading. We calibrate the sensor regularly and check the data with manual measurement. Fourth, there is a low adoption of farmers. To overcome this, we provide training and show the benefit of the system. Fifth is unexpected weather event may affect the equipment. We use protective cover and design the system for outdoor conditions. Six is there is budget overrun. Then we will monitor the expenses carefully and follow the planned budget. Lastly, communication gap among team members will occur. We hold regular meetings and update each other frequently. So by identifying the risk and preparing the mitigation plan, all of our project has run smoothly.
Hello, I'm Erica Thomas, and now let's take a look at our cost estimation for the project. For this initiative, we have calculated a total project cost of 150,000 ringgit. Breaking down the cost to ensure financial transparency, we have categorized these expenses into three main areas: direct cost, indirect cost, and contingency allocation. Firstly, direct costs. This cover the essential needed to get the job done, including all raw materials, necessary equipment, and the labor required for implementation. Second, indirect costs. These are the supporting expenses such as general overhead, utilities, and administrative fees that keep the project running behind the scenes. And finally, contingency allocation. We have also set aside a specific budget to manage any unexpected costs or emergencies, ensuring the project stays on track even if challenges arise. Moving on to our financial strategy, let's discuss the cash flow and financial analysis for this project. We have planned for a project cash flow period of 4 months. There are 3 key points to note regarding how we will manage the funds. We anticipate the highest expenditure will occur during the procurement phase as we acquire the necessary resource to start. To maintain healthy liquidity throughout the project, we are implementing milestone-based payments. This ensures that funds are released only as specific goals are met. And finally, our cash flow is strictly aligned with the project schedule to ensure that we have the right amount of capital available at every stage of development. This is the financial table. We begin with the site survey and system design. For this month, we focus on planning and labor with a total cost of 28,000. As you can see for the second month, this is our busiest and most expensive month at 69,000 ringgit. The cost is high because we are buying the majority of our materials and equipment, which alone costs 55,000. Now that we have the materials, we move into installation phase for the third month. Spending drops to 39,000 with the majority of the budget going toward labor and system integration. In the final month, we focus on testing and handling over the project. This is our lowest spending month at 12,000 ringgit, covering final checks and project closures. And for the 7,500 is set aside to cover unexpected costs that might happen during the 4-month period. As example, it can be used if material prices suddenly go up, if a piece of equipment breaks and need a quick replacement, or in case bad weather delays the site survey. Having these funds ensure that if something goes wrong, the project doesn't stop and we don't have to ask for more money later. This slide focuses on our payback period, break-even point, and internal rate of return. Essentially, we are looking at how quickly this project pays for itself and the quality of the returns we expect to see. First, we have factored in a 5% of contingency fund. While we aim to stay on budget, this provides a vital buffer to reduce the risk of cost overrun, ensuring that unexpected expenses don't disturb our progress. Secondly, we carry out a detailed sensitivity analysis to assess how rising material costs could affect our overall profitability. This helps us anticipate potential changes and respond early instead of reacting after market fluctuations occur. And the last one, project remains feasible under the moderate cost changes. Next, internal rate of return interpolation. To provide more technical detail on our internal rate of return, this slide shows the specific interpolation we use to find our final figure. Since internal rate return is the discount rate that makes the net present value zero, we use this formula to identify the optimal rate that presents our true internal return. We use 2 trial rates to narrow down the result. For the lower rate at 30%, our net present value was 4,500. While for the higher rate, at 32%, the net present value dropped to a negative 3,500. This means our true internal rate of return lies somewhere between the 30% and 32%. By substituting these values into the interpolation formula, we calculate the ratio of our positive NPV against the total range of net present values. We then multiply the ratio by the difference in our trial rate, which is 2%. As you can see in the final step, this adds 1.125 to our base rate of 30%. After rounding, the internal rate return is approximately 31.1%. Since the internal rate return is higher than the required rate of return, it shows that the project is financially viable and attractive for investment. That's all from me. Thank you.
For the next slide, I will explain about the budget feasibility for our project, which focus on the estimate cost and the financial benefit that we expect to gain. First, I will explain the cost component that involved. The project cost is divided into 3 main categories. The first one is direct cost, which include the materials such as sensor, microcontroller, pipe, and other equipment. It also covers the labor cost for installation and system development. The second category is indirect cost. There are supporting expenses such as electricity, internet connection, maintenance, and administration throughout the project period. The third category is contingency cost. This is an additional allocation prepared for any unexpected expenses like replacement of faulty device or price increase. Next is financial viability of the project. The automated irrigation system can reduce water usage because water is supplied based on real soil condition instead of manual estimation. It also can lower labor costs since farmers do not need to spend much time on manual watering and monitoring. Furthermore, the system helps to improve crop yield and quality by providing optimal water usage, which support better plant growth and reduce plant stress. Overall, although there are initial costs of implementation, the long-term saving and increased productivity show that this project is economically beneficial and sustainable. In conclusion, the budget flexibility proves that the project is worth investing and can bring positive return to the farmer and stakeholders.
Assalamualaikum. My name is Muhammad Fikrin bin Muhammad Arifin. Metric number 2313210054. Today I want to talk about entrepreneurship and innovation. This project focus on integration of Internet of Things, automation, and cloud computing in agriculture. By smart technology, this system help farmer monitor and manage their crop more efficiently. It supports smart and sustainable agriculture by improving productivity while reducing environment impact. In addition, the solution is scalable, which means it can be easily adopted by more farms in the future. It also reduces water wastage and lower labor dependency, making farming more cost effective and efficient. Lastly, for our group, the conclusion is the smart irrigation system effectively addresses the inefficiencies associated with traditional irrigation practice by introducing automation, real-time monitoring, and data-driven control. The project is both technically feasible and economically viable as it utilizes existing technologies such as IoT sensor, automatic control system, and cloud-based monitoring within a realistic budget. By reducing water wastage, energy consumption, and labor dependency, the system provides long-term sustainability and significant cost saving for farmer. Furthermore, its scalable design and practical application make it suitable for real-world implementation, particularly for small and medium-scale agriculture operations seeking efficient and sustainable irrigation solution. That's all for our group. Thank you.